Alright, Geometry 2-3, two-dimensional figures. Alright, so we have some basic formulas here. Alright, your basic formulas are along the left side, perimeter area of a triangle, square, rectangle, and a circle. Okay. Remember, with a circle, that the radius goes from the center to the edge, and the diameter goes all the way across through the center. And then you have two vocabulary words here at the bottom. You have the convex polygon. No points of lines are in the interior, so convex. And you have concave, where some of the lines pass through the interior. Okay, so convex versus concave, some of the terms that you will see. So finding the perimeter or circumference and area of each figure. All right, so basically what we're doing is we have two coordinate points, and we are finding the distance basically diagonally across a coordinate grid. So we're going to use the distance formula a lot for this section. Okay, so in order to find the circumference or the area of a circle, you must find the radius. So that is what we have to find first, is the radius of our circle. So from the center point, which is 4/8, out to the edge, which is 6/3 for this one, we have to find the distance. So we use our distance formula. Okay, your distance formula, it's the square root of your change of x squared plus the change in y squared. All right, so first one we're going to do is we're going to find the distance of the radius. So this is just our distance formula. All right, so we have our 2 points, and that's just what the little subscripts mean. So I'm going to write, so let me see, x1 is 4, y1 is 8, second point, x2 is 6, y2 is 3. So I just write them out and label them, and then since it's a formula, I'm just going to plug them into my formula. So we've got the radical symbol, the really big radical symbol. All right, so x2 is 6 minus x1. Make sure we square those, plus y2 is 3 minus y1, which is 8. And we're going to make sure we square that. So again, the big radical symbol. 6 minus 4 is 2. We can't forget to square it, though. And then 3 minus 8 is negative 5. Well, we need to remember to square that. Keep going. 2 squared, 2 times 2 is 4. Negative 5 squared is 25. And we add these together under the radical symbol, and you end up with the square root of 29. Now, normally, if we were stopping there, we would find the square root of 29, and we would round it to a decimal, but we're going to leave it as the square root of 29 because we must use this, okay? So we've got to use it. So the very last step you always do is round your answer. So we're going to be using this, okay? Because this is R. This is R. And because to find this circumference, it's 2 pi r. And to find the area, it's pi r squared. Pi is standard for mathematics. When you see the pi, we use 3.14 mathematically. Now but I'm going to put the 3 ellipses behind it because it keeps going. It never ends. Pi is one of those numbers that it's the only number that has no ending. It keeps going and going and going. And there are actually scientists out there who are trying to find the end of pi, and they haven't yet. And they just keep going, and they just find another digit and another digit. So it never ends. So in order for us to math with it, we say pi equals 3.14. All right, that's just a mathematical given. It's like, we have a formula. Area is pi r squared. or length times width. It's just something that's a given in math, a standard given that is assumed to be well known. So let's see, circumference, we got 2 pi 3.14 and times r, which is the square root of 29. So when I put this in my calculator, I was using a standard calculator, nothing special. I would find the square root of 29 first, and I would multiply it my way backwards, times 3.14 times 2. All right, so you get this ugly number. So I am going to take it one place to the right. I'm going to say this is 33.8 because I'm rounding to the nearest tenth. So it is about, or approximately, 33.8. All right. And we don't have any actual measures, so units, whatever the unit we are measuring in is approximately 33.8 is the circumference, so all the way around our circle. Now let's find the area, okay? Because the circumference is around the outside, and area is everything inside, all right? So let's find our area. Area is pi r squared, okay? So pi 3.14. R, which is the square root of 29 squared. Now, I believe I've mentioned before at some point, I think it may have been week 1, squaring and square rooting are opposites of each other. Okay, so opposites. So if you square something, or you take the square root, when you do both of them at the same time, they're opposites. Just like addition and subtraction are opposites, multiplication and divisions are opposites. And because they're opposites, when we math, they undo each other, okay? Or they cancel each other out. So our opposites, when we are doing the exponents, squaring is the opposite of square rooting, and they cancel each other out. So for squaring, square rooting, those actually cancel each other out, and you're left with 3.14 times 29. Now, because we're dealing with pi, it's going to be an approximate. So 3.14 times 29 is 91.1 if we round to the nearest tenth. Or you could put 91.06. Okay? 91.1. Just rounded it to the nearest tenth, that's all. It didn't tell us to round, but typically we do round either to the nearest tenth or the nearest hundredth. I'll take either. Okay, so remember summaries, when you finish your notes, you go back the next day and you think about your notes, what was the most important parts of it. Now we can use real world things to model this. So here, it doesn't look, you can't really see it on the notes, but in class, this is actually a platter of Roma tomatoes. So the platter part didn't really show through. The platter was, I believe, white, and so it didn't copy well. So this is actually a square platter full of Roma tomatoes. All right, so it's supposed to be a real world example, but it didn't copy well. So 12.5 by 12.5. So if these are the same, then this serving platter is the same as a square. So to find the perimeter and it says right here, round to nearest tenth if needed. To find the perimeter and area, we look at our square. So perimeter is 4s and area is s squared. So perimeter is 4s, area is s squared. So now it's solve. So s just means side, so the length of the side. So perimeter is 4 times 12.5, and that is 50 inches, because we actually have our measurement, it's inches. And then our area is 12.5 squared. And when you square that in a calculator, that's approximately 156.3 inches squared. Because it's inches times inches, 2 dimensions, so it's inches squared. If it was 3 dimensions, it would be side times side times side, which is height, which would give me inches cubed. We'll get more into that later. All right, so let's have a real world application. So this real world application is a small cafe. So we have this small cafe. It is a 15 by 15 cafe. Each unit on the ground equals 1 foot. That's a standard conversion when you see little floor plans. And we're going to find out how much actual free space is in here to see what is the max occupancy we can have for our fire code. So we have our 15 by 15 space. So we have to find the area of our cafe counter and take that out of our total area. We have our triangle drink counter. We have to find the total area of that and take that out. And then we also have 2 tables. We have to find the area of these 2 tables, and we have to subtract them out from the area of the entire square footage of our cafe. All right, so find the total area first. So 15 times 15 is 225. All right, then it steps it out for you. So first thing we're going to do is we're going to find the area of the counter and sink station. So we're going to say C for counter, and you can count it off, and it is a 3 by 11 counter, which means it's 33 feet squared. Again, 2 dimensions, length times width. And we're talking about feet. All right, now my drink station, we're going to call that D. Okay, and it is a triangle, and you can look on front. Your triangle formula is 1/2 base times height, and you can count it out, and it's 1/2 times 5 times 6. And you put that in the calculator, and then you end up with 15 feet squared. So we have done our counter. We've done our drink station. Those were the 2 easy parts. Now let's do these 2 tables, which of course are at a diagonal. So we have to use our distance formula that we learned on the front to find the length and the width. Once we find the length and width using the distance formula, then we have to multiply length times width to find the area inside of this table that it's occupying, the space. And because there are 2 tables, you're going to multiply it by 2. All right. So our distance formula, I'm going to write it over here. D equals the square root of change of x squared plus the change of y squared. All right. So I am going to, for my length, I'm going to say x1 is 3, y1 is 9, that's this point here. My x2 will be 1, y2 will be 5. Length. The square root of, all right, let's fill it in. x2 squared plus 5 minus 9 squared. All right, keep going. 1 minus 3 is minus 2 squared plus minus 4 squared. Keep going. Minus 2 squared is 4. and then plus 16, which is negative 4 squared. And that equals square root of 20. We're going to leave that just like that for now. I'm going to switch colors just so our math doesn't run into each other in this section. And we are going to do the width. All right. Now for your width, your x1 is 5, your your x1 is 1, and your y1 is 5. Sorry, we're using this point again. And then we're going to use this point. So our x2 is 3, our y2 is 4. Again, we fill in our formula. So we've got x2, which is 3, minus x1 squared plus your change of y squared. Alright, 3 minus 1 is 2 squared plus 4 minus 5 is negative 1 squared. 2 squared is 4, negative 1 squared is 1. That equals the square root of 5. Alright, so I have my length, I have my width. Now I'm going to do the actual math for the table over here. So your table's a rectangle. Alright, so to find the area, that is your length times your width. Well, your length is the square root of 20 times your width, which is the square root of 5. Square root of 20 times the square root of 5, well, that equals the square root of 100. Well, the square root of 100 is 10. So your table area is 10 feet squared. And that's one table. All right, how many tables we got? 2. All right, next step. Find the amount of free space available for Isaiah's customers. All right, so we have our original 225. We subtract out our counter, the one counter, minus 33. We subtract out our drink station, which is 15. And then we're going to subtract out, we have 2 tables, so 2 times 10. All right, or you can say 20, okay? So 225 minus 33 minus 15 minus 20 makes 157 feet squared. That is the amount of free space we have in this cafe. Now we have to convert that. We have to see how much each person is going to occupy, okay? So it says there must be 15 square feet of free space for every one customer. All right, so you need 15 feet of space for one customer. Well, we have 157 feet. So you have your 157 feet. Well, each customer needs 15 feet. So let's see, we math that out. 157 divided by your 15. That's 10.46. That repeats. Can you have 10 and half a person? You can't have a fraction of a person, right? You can't have 4/10 of a person. That doesn't work. You can't cut someone in half and place them in the cafe. So the maximum amount of occupancy is 10 people. Now, was that a lot of work? Yes. Do small business owners have to do this? Yes, they do, because they have to make sure they are in compliance or they will be fined. So math is everywhere. All right, so this is your assignment, okay? We're really learning the distance formula with our assignment. It does take a little while. Please practice it, and good luck.